Hello students, we are going to start our third chapter, Atoms and Molecules. In the first chapter, we have studied about matter. What is matter and how it is divided into solid, liquid and gas. In the second chapter, we have studied that matter has been divided as pure. Now the question arises, how does the matter is made up of? Matter is made up of small particles. How it has been discovered? We are going to discuss this topic in this chapter, that is atoms and molecules. Indian philosopher Maharishi Kanand postulated that if we go on dividing the matter, we get smaller and smaller particles. Suppose if you take a matter, like suppose if you take a pen, break it into pieces, what you will get? You will get small particles. And he named these particles as Pramanu. Similarly, Greek philosopher also put forward the same idea. They called the smallest particle as atoms. Indian philosophers, they call the smaller particles as Pramanu, whereas the Greek philosophers, they have given the name as atom. Indian philosophers suggested that atoms may not exist in the free state, but may exist in the combined state in the form of species called as molecules and or compounds. This you have studied about molecules and compound. So Indian philosophers, they told that these small particles, that is atom, they don't exist in the free state, they exist in the combined state. Suppose if an atom of oxygen, it exists in the combined state in the form of O2 or H2O or CO2. Okay. So, by the end of 18th century, scientists recognized the difference between the elements and compounds and naturally became interested in finding out how and why the elements combine and what happens when they combine. See, they told that the Indian philosophers told that atom does not exist in the free state, but they exist in the combined state. If they exist in the combined state, the question arises why the elements combine together and to form a compound or a molecule. To get the answer for these questions, we have to go through this chapter. Anthony Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. So we are going to study about the laws of chemical combination. What are laws of chemical combination? The following two laws of chemical combination was established by Lavoisier and Joseph L. Proust. The first law is law of conservation of mass and the second law is law of constant proportion. Law of chemical combination consists of two laws, law of conservation of mass and law of constant proportion. Today in this session we are going to study about only the law of conservation of mass. What it states, it's an important law, you have to study. What it states that can neither be created nor be destroyed in a chemical reaction. That is, total mass of reactant is equals to the total mass of product. Suppose an example if we take calcium carbonate. Calcium carbonate formula is CaCO3. Okay. Suppose if I have taken 100 grams of calcium carbonate and I had it. Try to learn the chemical formulas. By the end of this chapter, you will know how to write the chemical formulas. Okay. We have taken calcium carbonate. What we have taken? Calcium carbonate. If you take calcium carbonate and heat it, what will happen? You will get calcium oxide plus carbon dioxide. 100 grams of calcium carbonate you have taken and you will get 56 grams of calcium oxide and 44 grams of carbon dioxide. Means reactant, how much mass you have taken in the reactant? Mass of CaCO3. What is the mass of CaCO3 you have taken? 100 grams. Calcium carbonate you have taken 100 grams and you have heated it. Then it will decompose into mass of calcium oxide plus mass of carbon dioxide. This is product. This is reactant. We call this as reactant and we call this as product. So mass of reactant is 100 and mass of product is, that is mass of calcium oxide and carbon dioxide, is 56 plus 44. That is also equals to 100 grams. So this is law of conservation of mass. It states that mass cannot be created. You cannot create the mass. You cannot make the mass. You cannot create the mass. Mass can neither be created nor be destroyed in a chemical reaction. If you have taken 100 grams of reactant, that is, if you are taking 100 grams of calcium carbonate, you will get the product also 100 grams. That is, mass can neither be created nor be destroyed in a chemical reaction. That is, mass of reactant is always equals to the mass of product. This is law of conservation of mass. Again, I'll state the same same law. That is, it states that mass can neither be created nor be destroyed in a reaction. That is, the total mass of reactant is equals to the total mass of product. This is the example we have discussed. That is, total mass of reactant calcium carbonate is 100 grams. The total mass of product, that is also you will be getting 100 grams. So hence law of conservation of mass is proved. Now how to verify? Experiment to verify the law of conservation of mass. How can you verify the law of conservation of mass? So, in order to verify the law of conservation of mass, we prepare a solution of barium chloride. Okay, we are preparing a solution of barium chloride by taking 2 grams of barium chloride and dissolving in 10 ml of water. And the second solution, you are going to take sodium sulfate. Sodium sulfate is Na2SO4. Try to learn the formulas. A solution of sodium sulfate, that is Na2SO4, by dissolving 2 grams of Na2SO4 in ml of water. Now take the solution Na2SO4 in a conical flask. So we are taking a conical flask. See, I am drawing a figure here. I have taken a conical flask. This conical flask is fitted with a cork. Okay. So in this 10 ml of sodium sulfate we have taken. Okay. This is 10 ml of sodium sulfate and the solution of BaCl2 in a small test tube. I am taking the solution of BaCl2 in a small test tube. This test tube also we are placing in the conical flask. In this test tube we have taken 10 ml of BaCl2. Now this test tube is taken in the conical flask by tying through the thread. Okay. Hang the small test tube in the flask carefully so that the solution do not mix and put the cork on the flask. So we have hang the test tube in the conical flask so that the solution does not mix. Now weigh the flask carefully. Now we are going to measure the content. We are going to weigh this flask. Next, now tilt the flask so that the solution get mixed. Now tilt it. Tilt it means loose the thread so that the test tube falls into the solution. What will happen when the test tube falls into the solution? See, the figure will become like this. The test tube falls into the solution. What will happen? The solution, both of the solution will get mixed. When both of the solution will get mixed, what will happen? The reaction will take place. Okay. Now weigh it again. Again you weigh this conical flask in which the test tube has been tilted. we observe that mass comes out to be same as it was before the reaction. So this proves the law of conservation of mass. So the weight of both the flask before it is tilted and after it was tilted, it comes to be the same, because the mass cannot be created, the mass cannot be destroyed in a chemical reaction. Okay, so this is law of conservation of mass. What the law of conservation of mass states? The law of conservation of mass states that mass cannot be created nor destroyed in a chemical reaction. That is, total mass of reactant is equals to the total mass of product. It's an important question you have to learn. Now moving on to numerical. First numerical, when 4.2 grams of sodium hydrogen carbonate is NaHCO3, is added to a solution of hydrochloric acid, that is HCl, weighing 10 grams, it is observed that 2.2 grams of carbon dioxide is released into the atmosphere. The residue left behind is found to weigh 12 grams. Show that these observations are in agreement with the law of conservation of mass. You can get these kind of questions, these kind of numericals from this law. So, first thing, frame a equation. Sodium hydrogen carbonate is added means plus, to a solution of hydrochloric acid. Sodium hydrogen carbonate is added to a hydrochloric acid solution. It is observed means reaction has been done. 2.2 grams of carbon dioxide is released means coming out. So carbon dioxide is released into the atmosphere and the residue is left. So residue is left. Try to frame this equation. If you try to frame this equation, automatically you can solve the numerical. Now, after framing this equation, try to write the weights at the bottom. Sodium carbonate is 4.2, hydrochloric acid is 10, carbon dioxide is 2.2, residue is 10. We know that law of show that these observations are in agreement with the law of conservation of mass. What is law of conservation of mass? Mass of reactant must be equal to the mass of product. What is mass of reactant? Mass of sodium carbonate plus mass of HCl. 4.2 plus 10, 14.2. Similarly, mass of product, that is mass of carbon dioxide plus mass of residue, that is 2.2 plus 2, that is 14.2. If you are getting mass of reactant is equals to mass of product, then law of conservation of mass is proved. In this way you have to solve. Next, what mass of silver nitrate will react with the 5.85 grams of sodium chloride to produce 14.3 grams of silver chloride and 8.5 grams of sodium nitrate, if the law of conservation of mass is true? So try to frame the equation. What mass of silver nitrate will come here, will react means plus with sodium chloride, to produce means arrow, silver chloride and sodium nitrate. See, what mass means X. 5.85 of sodium chloride, 14.35 grams of silver chloride and 8.5 grams of silver nitrate. We know that total mass of reactant is equals to total mass of product. What is mass of reactant? That is mass of silver nitrate plus mass of sodium chloride. If you don't know the formula, write the name here. Okay. Similarly, mass of product is mass of AgL plus mass of NaNO3. Mass of silver nitrate X, 5.85, 14.35 and 8.5. Add this and subtract this, you will get the value of X. See, these questions are quite easy. Only the thing is to frame the equation. If you are able to frame the equation, you can solve any kind of question. Okay. Till here, today we are going to stop our topic till here, that is law of conservation of mass. Thank you.